So today, the goal is to talk about Fleet server deployments and whatever things that we find interesting as far as that goes. My instinct here is to talk a little bit about like TLS and how clients, both web browsers and agents, talk to the Fleet server. And I'm not sure that like TLS is going to be super familiar to all of you. So maybe we'll talk a little bit about like what certificates are and like what TLS does. And then just like look at what do we give people as far as Fleet binaries and what does it look like to deploy it, and like what are some of the challenges. And I think some of the most common challenges that we see people having is like things to do with like the certificate name doesn't match the the URL that is actually trying to be used by the agents to connect, and like problems with debugging that. And yeah, so that's like idea I have. There's no concrete agenda, and I guess if there aren't questions immediately, I'm just gonna kind of dig into some of those things, and please feel free to stop me at any point and we can dig further into anything that folks find interesting. And yeah, we're just gonna go pretty free form, see how that goes, and then see if we want to continue doing this and change things up in the future. How does that sound? Cool. All right, so to go kind of to the most foundational aspects of this. So like TLS stands for what? Transport layer security, and it's basically like a layer on top of HTTP that allows us to have an encrypted and secured connection between clients and servers. When we say clients, again, like I said before, we're talking about a really common client on the internet is a web browser, but clients can also be applications like OS Query. They could be apps on your phone or apps on your desktop computer. And all of these things, like a common thing that we have interest in doing is connecting to other computers, to servers. And there are a couple of things that we would like to be able to assure when we do that. One being, is this server that I'm talking to actually who I intend to be talking to? Because I don't want to be like connecting to some hacker's website and then sending my banking credentials over. And then another thing that I might want to do is, if anyone's listening to the traffic between me, and even if it's a legitimate server I'm connected to, if that server is my bank, again, I don't want an attacker who's listening to all that network traffic to be able to see the contents of my traffic. And this applies also to OS Query. People consider a lot of the data that OS Query sends to be sensitive. People consider, in particular, like the enrollment secrets and the node keys that are transmitted when clients enroll to a Fleet server to be sensitive, because if an attacker gets hold of those, they can then end up impersonating the devices that are connected to us. So those are all kind of motivations for why we need to have a secure connection between the agent, OS Query, and the server. And then from the client perspective, it's kind of back to the same stuff as the banking example, where it's like, in particular, the credentials, the cookie value. Actually, we don't use cookies. But we put a session token into an authorization header. So that's sensitive. If that were to be revealed, then you could impersonate a user and then get access to all of the data that Fleet has, and of course also the password and that kind of thing. So all of that is motivations for wanting to have a secure connection to the server. And for some of you, this is probably super basic, and I'm probably like making up some, I'm probably saying some things that are not quite true. And if you feel like it's important, please feel free to interrupt me and correct the things that are probably most important. Welcome, Tutor, by the way. Great to see you here, Tutor, and sorry for the late notice on this, but I think that I'll definitely remember to add you to things like this in the future. This is the whole engineering team right now, Tutor, except for we have a contractor, Ben, who's not here at the moment. And yeah, glad to see you. We're just, right now we're talking about a little bit of background on TLS and like secure connections between clients and servers. So, the way that we typically on the internet do this secure connection thing that we'd like to do is through TLS. And the primary mechanism for that is we have this notion called certificate authority, which is considered to be like a trusted entity out there that we can rely on to give us information about the identity of servers on the internet. There's much discussion in the industry about whether certificate authorities are actually trustworthy, and all sorts of issues have been found in the past in terms of certificate authorities being less than authoritative or less than trustworthy. So this is something that is on some folks' mind. But in any case, imagine like we want to serve our Fleet server, claiming that it's fleetcontrol.com or something. We would essentially go to a certificate authority, make a request for a certificate, and they would ask us to do some sort of verification, which would probably involve like setting some values on that server over the DNS, but we don't need to get too much into the details. And then they would use that to validate that we do actually have control over that domain. And then they would issue us a certificate that basically says like DigiCert, one of the well-known certificate authorities, certifies that this certificate belongs to fleetcontrol.com. And then we would use that certificate, we would present that certificate to any client that tries to connect to us as a sort of proof that we are fleetcontrol.com. This uses public key cryptography, which is okay. I'm going to try not to go down too many rabbit holes here, but this uses public key cryptography, which essentially means we have a public and a private key. The private key we keep privately to ourselves. The public key we can share widely. And then when someone connects to our server, essentially the public key is well known and is part of the certificate, and we hold the private key. And they can ascertain that they're talking to actually us by essentially doing like a challenge and response mechanism. And then they negotiate a secure connection to our server. So there's like a lot of stuff there that I just covered in like 10 words, but in some very basic sense, that's kind of what's happening. Are folks following so far? Any questions?
So that was all about answering the who question or verifying the who.
Yeah, so mostly about verifying the who, and in addition, this negotiation occurs that while the client, so the browser or OS query or whichever client it is, while the client is doing that validation of the who is this, there's also a negotiation that happens that essentially decides on a cryptographic key that's shared between both the client and the server that is used for all the communications during the current session. And then that is what's used to secure the connection from, like, say, an eavesdropper once we've validated that we're actually talking to the correct server. And there's probably, I'm fudging that a lot. There's like people have spent a lot of energy into making sure these things are as secure as possible, and many flaws and stuff have been found, and we hope that it's not me implementing that stuff. This is why we always use like the standard libraries to do these things and blah blah. Okay, I don't know. I think I'm going off onto a tangent here, but the idea is, yes, we can validate that we are the server that we say we are, and we can establish an encrypted connection with the client. So I guess the question I'd like to come to next is, how does this connect to directly and practically to deploying a fleet server? So what I will do, I think, is share my screen, like where a user might go if they're trying to run a fleet server. So they might go to our releases page and download a fleet binary. So we can download the Mac binary. Oh, it won't be happy to run it because, oh, that's fleet control. My Mac won't be super happy to run this because we still have not started signing our binaries. Nevertheless, we can convince it to open it.
Would you mind going over signing? Because from what I know about it, it feels really arbitrary and I don't quite understand it.
Yeah, so yeah, totally. So that warning that I just very quickly clicked through is a warning from Mac OS, essentially saying, like, you're trying to run this software and we don't know anything about who published this software, and we're trying to protect you from running malware, essentially. And similar to this situation where we want to validate that, like, the domain that the server that we're talking to actually represents the domain that that we believe we're connecting to, we may want to also do, and we often want to also do, similar with the software that we're executing. Mostly because there's a lot of malicious software out there and we want to be able to understand what we're executing. So in order, one mechanism that we use for doing that is, again, this public key cryptography that allows these public keys to be well known. Private keys are closely held and protected. And essentially what we can do is we can sign with our private key the binary that we publish, or maybe it's some metadata about the binary. And this kind of thing varies by platform. So it's different on Windows, Mac OS, and Linux. But essentially, the process is always going to be something like, we take the contents of the binary, we make like a cryptographic hash of it, which basically means we generate a small string from, like, this. Okay, so this is a 40 megabyte binary. We generate like a small string that's something like a few hundred bytes, that could be that can be deterministically generated. So anyone could generate that string to verify. And then we use our private key to sign a message that says, this is the valid signature, this is the valid hash for the binary. And the user can validate, based on the well-known public key, that this was actually signed by us. And so on Windows, for example, we just applied for a Windows code signing certificate. And in order to get a code signing certificate that said Fleet Device Management, Incorporated, we basically, I think they sent us a piece of mail to our address in San Francisco, which is actually like, it's like get the physical piece of mail and give them a code that was on the mail. And they take that as satisfactory proof that we are, or at least the person initiating this process was us. And then they give us that certificate that we can use to present to Windows, or to the user of Windows, that this signature that is attached was actually signed by us. It's a similar process on Mac, except it's actually Apple issues the certificate for you. And there's also some other things that happen on Apple. In addition to just the code signing, they also have a new thing that they call notarization, which is where you actually have to upload a copy of your binaries to Apple. And then Apple will do some sort of unspecified process on them, but presumably doing analysis on the binary, like automated analysis on the binary, looking for malware. And then they'll send you another essentially type of signature that you attach to the binary, and that Mac OS checks when you start up a binary. So there's lots of different mechanisms for these things. They all vary by platform, but almost all of it is going to boil down in some sense to like this public key cryptography thing, where they're certificates with well-known public keys, and they're the closely held private keys that can be used to certify like I'm actually the person holding this key. And then there's some kind of authority who is just assumed to be trustworthy and is used to verify all the rest of these things.
Thank you. I did not know it went that deep. Thank you.
Yeah, and you know, so there's lots of things to go, you know, kind of wrong in every step of these processes, and they can and do go wrong. And for example, because there are so many ways for the keys and that kind of thing to get compromised, this is why we like spend quite a bit of time, or really we piggybacked on people who've spent quite a bit of time developing systems for securely signing metadata about binaries. And that's what we use to do the auto update system in Orbit. And that's why we got a security review of Orbit. And there are a bunch of things that came up that we need to address to try to close some of these gaps. But these things are likely to always be hard problems. So yeah, so I guess so in terms of the Fleet server itself, maybe we can pull up some of the Fleet documentation as well. So, you know, essentially the steps for installing Fleet are, in theory, it's pretty simple. You just unzip the binary and then you run it. And here we give a small section on the TLS configuration, but this is often the thing that trips people up quite a bit. So I'm going to start up my development dependencies. And I will try to run that Fleet binary. And so if we just try to run Fleet, we get an error because it wants a command. So if we try to run Fleet serve, then we get an error because we can't connect to the database because we haven't configured the appropriate database, probably. So we can try to configure the database, which should be now And we wouldn't encourage, so by the way, like right now we might go MySQL password equals, what is it actually? I think we're gonna have to,
I
look
think
at the
it's
Docker
root
file.
backwards.
Is it root? Oh, okay, cool. Thank you, Thomas. Oh, and we don't allow you to do that because that's not a good idea. No, we do allow you to do that, but we still recommend somewhere in the docs that you don't do that.
I think you put tour.
Yeah, it's
Or root backwards. Oh.
no, but it's neither of those. But to point out, just to quickly point out why we don't recommend such a thing. Now there's a history file. Oh, let's look at tail. There's now a history file sitting on my system with that password sitting in there. And so this is one of the reasons why we recommend people would set passwords with environment variables. And you'll see that kind of recommendation, like for all sorts of different servers. You almost always want to keep your secrets out of command line flags because these history files are, sit there indefinitely. And often, and this is also an interesting kind of risk with OS query, where there are tables in OS query that pull the shell history. And so then and folks are interested in what's being executed on shells on the systems that they manage. And you can end up, if users are typing passwords into their shells through the commands like this, you can end up using OS query and Fleet to ship those passwords over the network into your log aggregation systems and potentially all sorts of places. So this is kind of an interesting vector for leaking information that might be unintentionally leaked. Let's see. So what is that? What is the password that we need? Or what is the configuration that we're missing?
Isaac, I posted in the chat the comment that I use,
Okay.
which uses, because you need, I think the host is localhost.
Yeah.
With port 3306.
Awesome. Thank you, Thomas.
And the username would be root. I don't know if it defaults.
Yeah. Let's see. And we still, and actually, before we do this, let me clear my MySQL database. So all right, so now we'll have an empty database. So we'll run the database migrations, which will give us now an empty database that actually contains the schema. And we can go back to our serve command. And here we get our error. It can't find the certificate that it needs to serve. And this is because by default, Fleet tries to serve with TLS. And the reason for that default, besides for that it's just default more secure, a big reason for that default is that OS query will just refuse to connect to any server that's not using TLS, because the OS query developers have decided that it's not worth the risk of making it possible for people to deploy OS query in a manner where they're not using TLS or where the TLS is improperly configured. And so this is kind of where the challenge comes from for our users of Fleet, is OS query, for some good reasons, wants to be very strict about this, and because of that, we have to help people get everything very precisely right. Is the text big enough in my terminal, by the way? Okay. So I think we could give it the path to that development certificate we use. which that is, I think, server key server cert, and that'll be and if we do this, then we get an error because the key can't be found. And note that if someone were deploying this in production, they would likely have to have already gone through the process of generating a certificate for the server to use. And that might have been a process of like doing the little ritual dance with the certificate authority to get them to issue you a valid certificate. Or you can also just generate your own certificate that you self-sign. That won't be, that I think you've probably all seen, especially when working with like a local fleet server. You've seen the warning that you have to click through that like, this is unsafe because the certificate is not trusted by a known authority. And so like, please click through here. Or you have to like click advanced and then whatever in order to make it work. And then again, that's because you can self-issue the certificate, but your browser is going like, well, we don't know who issued this certificate. It's not on our list of well-known certificate authorities. So with this set of commands, it looks like we got our fleet server up and running. And one thing I might do is to demonstrate what this would look like if I were deploying this on, let's say, fleetcontrol.com. Is we can edit our host file to kind of skip the DNS lookup process and treat fleetcontrol.com as the same as localhost. Haven't done this for a while, so we'll see if that was the right syntax. The server's running. And so right. So here's our browser warning that we were just talking about. If we look at this, it's going, the certificate's not trusted because it's self-signed. So that's that issue. That's very common. If we look at the information about the certificate, important things that folks are looking for or that folks need to look for when looking at these certificates, particularly in the context of Fleet and OS query, is that either this common name needs to match the host name that they're accessing it on. So that would be like localhost if you're running it locally, or maybe it's fleetcontrol.com in this case. Or one of these subject alt names needs to match that. And so this certificate that we use for fleet development and for fleet preview has a few common names that might be used in fleet development. So this host.docker internal is used in fleet control preview, I think, and localhost and 127.0.0.1 are both basically the same thing. And would go to that server as well. We probably won't get a warning here, or we do there. We might not get a warning here because we've already clicked through that warning for localhost, and Firefox has already accepted like, okay, you already know that this is not secure, so I'm not showing you the warning. But I haven't done this with this address or with this address, even though they all point to the same server. Firefox, as the browser, is looking for the server host name to match what's on the certificate. So we can accept the risk and continue. Any questions right now?
I have one slightly unrelated to what you've been saying. I'm curious to know, is there a situation where a customer deploys many servers? Or is it always just one server to many hosts?
Yeah, so our customers often deploy multiple servers behind a load balancer. And so essentially what happens is the load balancer becomes the address that you share with your clients. And so any connection that they make gets routed to the load balancer. Often the load balancer is the thing that does the quote termination of TLS. So it'll be the thing that presents the certificate, says I am the server, negotiates the encrypted connection. And then the load balancer will then fan out the requests to any number of Fleet servers. So the Fleet architecture is designed to accommodate any number of Fleet servers as long as they are connected all to the same MySQL and Redis databases.
So is
And
the
then-
benefit to pretty much have as many hosts as you want without performance issues?
Yeah, exactly. So this is a really common pattern for server deployment, is like, well, what do you do when the amount of resources that you need exceeds the amount of resources on the biggest machine you have? So that's one problem and one motivation for it. The other would be for reliability. People want to ensure like the highest uptime on their servers. And actually reliability is, in my opinion, not such a huge issue when it comes to managing OS query, because OS query clients are used to the server going offline, or at least their connection to the server being disconnected, because we're talking about laptops that are turning on and off and they're disconnecting from Wi-Fi. And so it's made to be very resilient to that. Nevertheless, people still want reliability on their Fleet server, and it's inevitable that even if not bugs in Fleet itself causing the server to crash, like at some point, if things are like you literally living in a data center physically, like someone's going to accidentally unplug something, or like the server is going to need to reboot for updates. And if you have, say, a minimum of 3 servers sitting behind that load balancer, then there will always be at least 1 or more that are ready to receive requests. And so that helps with the reliability as well.
That makes sense. Do the servers ever talk to each other, or is it just the load balancer handling that?
Yeah, so the servers talk to each other only through Redis and MySQL. They never talk to each other directly, like by making direct connections to each other.
Makes sense.
Yeah, and then so the servers don't, because of that, the servers don't need direct network access to each other. And like, for example, when configuring things in AWS, which is what I'm most familiar with, there's like this notion of security groups that determines what basically each endpoint within a network, what things it can connect to. And you don't have to configure security groups such that the Fleet servers can talk to each other. You just have to make sure that they can talk to the Redis and the MySQL, and that the load balancer can talk to them. Yeah. So yeah, so here we are. So we got our Fleet server running. If we go to our add new host dialog, we'll see that everything looks to be working fine, but we will see that we're going to run into problems with this configuration that we have here, mostly because of this address being fleetcontrol.com, but that not matching the certificate that we have. So the browser, we told it already, like, well, one, we told it it's okay that this is a self-signed certificate. And because we already told it, like, we're cool with an insecure connection, it's not even complaining to us that the name of the certificate doesn't match the name of the server. So if we download the enroll secret and flag file and server certificate, we can attempt to connect. I'm gonna just delete the old ones first. This downloads to what? Oh, fleet.pem. And flagfile.txt. Okay, so we can download each of these. And essentially we're following the instructions that we have here. And we will come back to our terminal and we can try running OS query. And now what we're seeing is like a super common error that our users get, which is certificate verify failed. We have some entries in the FAQ about like why this can take place, this may be happening. And it's not a super helpful error because it doesn't tell us why the certificate verify failed. And that means that it's unfortunately kind of left to the user as an exercise to determine what the issue could be. In our case, I know it's because the host name doesn't match. And we could look at some more information about that. For example, if we were to do a curl, we could try to curl. So curl is like, just make a web request. Our fleet server, so what do we call that? Fleetcontrol.com 8080. And curl is gonna give us basically the same error that we got from the web browser. So self-signed certificate. And we can do, we can add that -k flag to allow unsafe, essentially. And I'm gonna also add the verbose, actually, let's add the verbose flag to that previous command. Yeah, and we can see it actually presents some information about what was going on with that certificate. And here we see CA in this case stands for certificate authority. So this is saying like curl also has its own bundle, or maybe it uses the system bundle of known certificate authorities, and it says, okay, we don't know this one. So we can get around that by adding the -k flag. And we see all of this same information that we saw on the browser. So it's saying like, okay, this is a self-signed certificate, but we're continuing anyway because it was configured to allow that. Now I think let's see if we can find the flag to best demonstrate this. Yeah, I think this might do it. Yeah, so now we're simulating a little bit more closely what OS query is trying to do, because that OS query flag file, actually, let me show what the flag file looks like. So the flag file includes this flag, TLS server certs. It says use this certificate which is the one that we just downloaded from Fleet right here, use this to verify the server. And so we saw that if we turn off verification entirely, things work fine. But why is it failing here now? We can see it from here. So basically, it gets a little bit further this time, but it starts looking at the subject. This doesn't match. It looks at the subject alt name, and there were a few of those that we saw before, and none of those match either. And so it says, well, this is a certificate that's valid, at least we believe it's valid because it was part of this bundle. You told me these are the certificates I want to consider valid, but even though the certificate is valid, it's not valid for the domain name that was used. Because if we go back to Firefox, we see these are the only valid domain names for that certificate. And so I think I'm realizing now that I'm not sure we recommend folks to use this command. So this could be a good one to add to our FAQ for debugging this, which would help with with figuring out how to get the subject names to match. To resolve this issue, imagining we're a user really trying to deploy this on fleetcontrol.com, we are probably going to have to make sure that we generate a certificate that's actually valid for fleetcontrol.com. Or we can deploy it to somewhere that the certificate matches. So for example, if we can still access this server on localhost 8080. Oh, and I don't remember what I set for the username and password. Oh, admin@fleetcontrol.com. So the thing that we can note here is that these are the valid names. So if we change to, for example, localhost, will curl then validate this successfully? And it does. So now we have a certificate. So here it says subject alt name localhost matches certs localhost. So we have a certificate that matches successfully. And when we specify that bundle to curl, then things work out fine. The same will be true of OS query. So now if we edit this flag file and we say, okay, the TLS hostname is not fleetcontrol.com. It's actually localhost. Then we should, hopefully, when we run OS query, see it actually successfully connect. And we do. And now if we come to Fleet and refresh, we see that the host did actually successfully connect. And this is because OS query is essentially doing the same thing that curl was. It's going, okay, well, you gave me this certificate bundle, but none of the names actually matched. When the names match, it works. The other thing that won't work in OS query, which will go back to this being a self-signed certificate, is if if we were to remove this flag, which tells OS Query to use the certificates in this file, then OS Query will use, again, the set of well-known and trusted certificate authorities, and it will error again because this is a self-signed certificate that we're issuing, or that we issued to ourselves. And if we do this, we'll be back to certificate verify failed. Yeah, there. So was there a question there?
Yeah, I have a question about installation because I think something just tied together that I didn't realize. So the server runs Fleet and the host runs OS Query. Is that correct?
That's right.
Okay. Well, because basically doing development, we're just taking shortcuts. So
Right. Yes.
quite realize
Yeah,
that.
for sure. In development, the same host runs OS Query, or like we run it in Docker typically because that's been the easiest way for us to
Right.
do it. But in a real deployment, you deploy Fleet on a server within your infrastructure, and then you deploy OS Query to every device that you want to manage, and they all connect up to the Fleet server. And Fleet is kind of an interesting example of a server because we have a few different clients. We have the OS Query agents as clients, and those interact with endpoints that are basically like /API/v1/OS Query. And then we have the web browser clients, which interact with those endpoints /API/v1/Fleet. And then we also have Fleet Control, which uses the same endpoints that the browser does. But these things are, when we talk about users of Fleet, we're usually talking about the operators, the folks who are responsible for the IT or the security things at the organizations. And they are widely deploying OS Query to all of the devices in their network or in their organization. But the end users of those devices typically don't care about OS Query and don't care about Fleet, except insofar as people commonly blame security tools for performance problems on their machines, which may well be true. And because of that, OS Query has some mechanisms for trying to prevent sort of runaway performance issues. And also people worry about the surveillance, basically, which is something that we are looking to tackle with like our ideas of scope and audit transparency.
Is there a shortcut to deploying to thousands of devices?
Yeah, so typically it depends on the organizational sort of technological maturity. Hopefully by the time you're at thousands of devices, you have a good system in place for deploying software and configurations to all of your devices. So this is commonly things like Chef, Puppet, Ansible, or MDM tools like Jamf, or I think Mike was talking about Monkey yesterday as something some of our customers use and are interested in integrating a little more tightly with Fleet. So there's a bunch of different ways that you can deploy software and configurations to hosts. And typically we try, or we're in the process of trying to make this as easy as possible through the work that we're doing with Orbit, by making it so that for each platform, Mac, Linux, and Windows, you can generate a platform specific package that does all of the necessary installation steps, like puts all the files in the right places, puts that, that Fleet server certificate in the right place, tells OS Query to start with the right flags, this kind of stuff. Actually has OS Query start when the computer starts up and the user doesn't actually have to open up their terminal and start OS Query like I've just done here. This is obviously like unsustainable. We can't, like operators can't go like, oh, hey, by the way, when you log into your computer, could you please, run sudo square d dash dash flag file?
Right.
So we configure these things to automatically run with the right configurations. And so we give them a package, which essentially becomes, double click on the package and click next a couple of times and that installs. That would be like, if you're at the lowest level of organizational maturity, you might literally send that out to everyone on Slack and be like, hey, please double click this and install it on your machine. And if you're at the higher end of organizational maturity, then you push it out automatically with Chef or Puppet or Ansible or Jamf or VMware Workspace ONE or whichever tool you have. And that tool just runs the installation package. And within, minutes, you have it on every host that's online.
I have a lot to learn about IT. Gee whiz.
Yeah. And this also becomes a reason why for some of our customers and some of our open source users, things like auto update of the agent is very appealing, because if you are an organization where you have to do things like send people emails or Slack messages saying, please install this thing, like as the thing gets updates, or especially if it ever is found to have security vulnerabilities, and you have to like go to people and say like, please install this, like that's a huge burden for you. So if we can make it so that you only deploy the package once, and then you can manage everything going forward based on that, then we put those folks in a much better position. And on the flip side, if you're an organization with higher level of maturity, and it is easy for you to deploy these kind of packages, then you may see the auto updating functionality is actually a greater risk, because because you probably already have centralized processes for pushing out these kind of IT updates. You're probably doing like a GitOps kind of workflow with your configuration files, and you don't want to be able to get around those processes because you want to have good monitoring on what's happening. And so those organizations say, no, we don't want that. We'll just do it ourselves. But for both sides, we can make their jobs easier by making sure that like the packaging and deployment process is easy.
It's really cool.
Any other questions that folks have while we're here? Well, I think, we got into the weeds, I think, on some things, but hopefully it also helped people understand a little bit better, like how the agents and how all of the clients can securely connect to Fleet, get a little sense of like, what is this common deployment issue? And even like, what is, in the most basic sense, what does it take to deploy Fleet? We certainly didn't get to lots of things like how to deploy it more reliably or with higher performance by putting it behind a load balancer, which is something that people often want to do. We didn't get to things like, if I were really deploying this server for production, I would want to make sure that, for example, if the computer it was running on restarted, that the server would restart, or if the server crashed, that the server would restart. So there's more that has to be done, but this is a bit of a taste of some of the things.
Thank you. This is really great.
So awesome. Thanks, y'all. I'm going to stop the recording and maybe we could take 3 minutes, and then I'll see most of you at stand up.
Thanks,
Cool.
Zach.
Sounds good.
Awesome. Thanks. Bye.